I've spent 20 years developing clean energy technologies, and there's one question I've never been able to fully answer. How did China get so good at this so fast? Right now, I'm on a high-speed train heading to Hefei in China to visit some factories, and I'm genuinely not sure what I'm going to find. But I think it's going to change how I think about clean energy technology development. Let's go.
So here I am, I've arrived in Hefei, in Anhui province in China. I'm here for Sungrow's Global Renewable Energy Summit, which is a huge event with about 500 partners, employees and experts from around the world. I've collaborated with Sungrow before at Australia's All Energy event last year, so I'm really looking forward to seeing their home base. I'm most excited to see the factory tour and test facilities that I'm going to see this morning, and then there's going to be a bunch of opportunities to talk with experts and learn about how Sungrow is developing their products. I'm Rosie Barnes. Welcome to Engineering with Rosie. There's a question that comes up a lot when people talk about China's dominance in clean energy manufacturing. Why China? The technology wasn't invented here. Solar cells came out of Bell Labs in the US. The high efficiency cell architectures that dominate the market today were largely developed at the University of New South Wales in Australia. Germany were the first ones to install them in large volumes. And yet, China makes the vast majority of the world's solar panels, also inverters, batteries, and other clean technologies. So what actually happened? Part of the answer, I think, is about how different cultures think about innovation. Because to my Western ear, innovation and invention are basically synonyms. We place enormous value on the breakthrough moment, the genius idea, the scientist who discovers something new. That's the glamorous part of the story, the prestigious part. And this is one of my pet topics. I have talked about it before. Engineering, the work that comes after the glamorous part, tends to be treated as the grunt work, taking somebody else's idea and just making it. And actually, I sometimes get the impression that people think that this part is almost like cheating, like it's plagiarism to take someone else's invention and commercialize it. But if you actually want to change the world with a technology or, make money from it, you have to learn to make a lot of it and sell a lot of them. And the only way to do that is by improving manufacturing efficiency and driving down costs over time. This means that the grunt work isn't the follow-up act, it's the main event. To put it bluntly, if your country is only interested in genius discoveries and it's too good for the engineering that follows, then it's also too good to ever dominate. There's a law that describes this manufacturing importance. It's called Wright's law. It says that every time the cumulative production of a technology doubles, the cost falls by a consistent percentage. You can see it so well in solar panels and batteries especially, that inverters, wind turbines, other clean technologies follow that same smooth curve of falling cost over decades. But that curve is powered by engineering work. Every production run, you find a slightly better way to do it. Higher yields, less waste, better quality control, faster throughput. Small gains that compound over millions of units. So when I got the chance to go inside a Chinese factory and see how this stuff is actually made, I jumped on the chance because I am so curious to see what that engineering culture looks like up close. So Sungrow's manufacturing campus here in Hefei is, and I mean this literally, it's the size of a medium-sized country town. All of it Sungrow, and we got to go inside. I wasn't allowed to film in the factory itself, which is such a shame because it would have made great footage, but I took notes and recorded my thoughts straight after on the bus. Plus, I think they're going to give me some footage that I can show alongside it.
Okay, so factory tour over. There's a real shame that I couldn't film in there. First thing we saw was a pack production workshop. So they're taking battery cells. They're like the size of a a small cereal container, maybe like 2 soy milk Tetra packs, and then they assemble those into packs with I think they're like 26 or so cells in a pack, and then put several of those packs into a module.
Next, we visited the warehouse, and the scale of that was pretty staggering. They store about 1.8 gigawatt hours worth of battery cells in that single building. To put that into perspective, that's enough to power the entire city of Hobart for a day, or Sydney for 90 minutes. And when you've got that many cells and that much energy density concentrated in one place, fire becomes a really prominent engineering problem.
They've got 3 levels of fire safety in the batteries themselves, and then within the storage. They've got temperature sensing threaded all throughout amongst all of the batteries, sprinkler systems everywhere. And if they do get a problem, they can remove the effective battery, and if it's small enough, put it in this little fire containment system and put that out and isolate it while they're waiting for it to go out. But if it's a bigger fire, then they can take that outside and just keep it cool long enough for it to burn out. I did ask, and they haven't actually had a real fire in there, but they're periodically doing tests. They did tell me about one super cool test that they did, which was a 20 megawatt hour real world fire test. They took one battery, a 20 megawatt hour battery, disabled all of its fire systems, and set that on fire. It had still intact batteries surrounding it, and the battery burned for 25 hours, reached 1400 degrees Celsius at the hottest, and after all that, the hottest that any of the neighboring cells got was 40 degrees Celsius. And at the end of the test, the one that was burnt out was still structurally intact, which is important because then that means that you can use equipment to remove it safely. And apparently that test cost them 300 million renminbi, which is, I think, about 50 million Australian dollars, big by 40 or something US dollars.
From the battery side of the factory, we moved over to inverter manufacturing. And this is where there was an amazing clean room moment. Man, I wish I could have filmed the crazy outfits that they had us put on.
It was a inverter manufacturing facility which had some very long bus production routes. I think that it's just really clear that everything was set up to not be moving any more than you need to. It's just speed is the name of the game, and utilization. Obviously their equipment is very expensive, so they're just using it non-stop. There's never a second, basically, when a machine isn't doing anything. They've got to wear these amazing dust-proof outfits with yellow hats, shoe covers. We walked inside a little room and air jets blew the dust all off us. So
the reason for all of that is consistency. Because in electronics manufacturing, contamination is one of the main causes of early failures. Moisture, dust, particles getting into connections. So keeping the environment controlled isn't about being fancy. It's about making sure that the 10,000th or 10 millionth inverter off the line is identical to the first one. Aside from the cleanliness, what struck me about the inverter manufacturing lines was the speed.
The initial thoughts from the factory visit were just the scale. It is gigantic, all these massive warehouses, solar panels on all the roofs, but things are going pretty much all robots making everything except for humans. They're obviously supervising, but also doing some of the frame installation, stuff like that. Mostly they're using robots for the processes where speed is really important or where quality is really important. They're using AI quality control, a lot of pick-and-place robots. In the inverter manufacturing facility, the speed that the pick-and-place robots were inserting components into circuit boards for inverters was just insane to see how fast that they were moving.
Now, I want to be clear about something, because it would be easy to watch all of this and think, okay, robots and automation, that's just money. Anyone can buy a pick-and-place machine. And that's true. The individual processes, at least the ones that I was allowed to see, aren't all that secret or exotic. What's actually hard is the system design around them. You can't move a circuit board to one station for component placing, then somewhere else for soldering, back again for more components, and off to another room for coding. Every unnecessary movement is wasted time, wasted space, wasted cost. The real engineering challenge is laying it all out so that everything flows continuously. Nothing waits, nothing travels further than it has to. That's what I was seeing in that inverter line. And it's one of the main reasons why replicating this kind of manufacturing from scratch is way harder than it looks on paper. Even if you can do every single process fine, you need an immense scale to be able to set things up so that you can have that very, very efficient system and the whole thing working just constantly. And that same logic, design the whole system, not just the individual parts, that's what made the last stop on the tour my favorite.
And the final one we went to was Evertest, which is a testing company. It's a wholly owned subsidiary by Sungrow. They've got 100 different kinds of tests that they can do, some really cool stuff. They actually have a lightning testing machine in there. So they're testing up to 30 kiloamps to make sure that residential systems can survive a lightning strike. Then there's also a whole bunch of environmental testing, super low temperatures, super high temperatures, wind-free environments, monsoon environments, mountainous environments, snow, humidity, high humidity, everything that you could think of to test it. They also had a big concrete pitch where you can put a battery and safely do a fire test in there, purposely set things on fire, things like that. That was one of the funnest parts of the tour.
All right, day 2, and now I'm about to head to the workshop where Graham from Sungrow is going to tell me about residential products with a specific focus on the Australian market. I've got a bunch of questions ready to go because after what I've seen in the factory and the test facilities, I want to understand how all that engineering translates into what customers actually experience.
And what aspects do customers care about the most in these products? Is it just cost?
The reliability and, of course, the service backup. We actually have a service centre and a tech support centre in Sydney, open 6 days a week to help end users if there is something wrong, or even if it's just a query. Not only that, but we do provide data logging and it comes free on the app. And in here is all the data you need. It's got real-time data, weekly data, monthly data, yearly data, and it'll even tell you how much you're saving.
Safety and reliability are key concerns.
Yeah.
What are you doing to make sure you're standing out in those areas?
Yep, there's a lot of bad press about batteries. I don't know why this is. We test these on multiple levels to make sure that they're absolutely 100% safe. And they also have inbuilt systems to keep them safe as well.
All right, now it's the end of the trip, and I came here with a hypothesis that the way Chinese clean energy companies like Sungrow have gotten so cost competitive is through their prioritization of engineering and relentless process improvement. And what I saw, I think, did confirm that, but it was also so much more than I expected. The testing specifically was not something that I was aware that they were doing to such a vast scale. The fire test alone, $60 million on a single test. And then the rest of the test facility, especially the monsoon wind wall blasting solar panels. Also the level of automation in the inverter line. Those are the things that I keep on thinking back over. I've made quite a few videos about China's clean energy sector, but before now I never had the opportunity to experience it in person. So I am incredibly grateful to Sungrow for inviting me to their Global Renewable Energy Summit and treating me so well. I actually had to buy a second bag to get all the gifts I was given home again. I can't say that I ever thought I would be a 43-year-old engineering influencer, but here I am, and I've got to say it's very enjoyable. If you're into this kind of engineering deep dive, then please subscribe. There's a lot more like this coming, and consider joining the Engineering with Rosie Patreon or become a YouTube member. I was actually in the Discord with a few of the members, and they were asking me, can you look at this thing that they're doing in China? And I was able to go film little bits and share. So that's one of the kind of fun things that you can do if you're part of the team. Thanks for watching, and I'll see you in the next video.